Will an UltraStik 360 analog joystick work with a Brook Wireless Fight Board? In this video, we're going to explore that very question. Now, this was a science experiment for me. I had no idea when I started this video if it would work or not. So the video is longer than what I wanted it to be, so I'm going to put markers inside of this video so you can fast forward to the parts that you want. First, I'm going to explain the difference between a potentiometer type joystick and the UltraStik joystick. And then I'm going to explain why there are some issues with the UltraStik on the Brook board. And then I'm going to show you how to fix it. And then after I fix it, I'm going to show you all the testing that I did to verify that the fix I did worked. Spoiler alert, yes, this joystick will work with a Brook Wireless Fight Board, but you're going to have to add some pieces in order to make it work effectively. Now I have two of these wireless fight boards, and I built two controllers using the UltraStik 360 joysticks. One of the controllers worked with the UltraStik joystick, the other controller did not. And by not working, I mean it had severe joystick drift, so it was pretty much unusable. And then the first one that did work, it only worked temporarily. So that's what made me make this video in the first place. I wanted to get down to the root cause of the problem and see if I can fix it. I do plan to make another video that just focuses on the fix itself. So be on the lookout for that. If you're only interested in fixing the problem, I'll do it much more short and to the point. But for now, you're going to have to live with what follows. Please enjoy. Thank you. Let's talk about how a PS4 analog thumbstick works. So I'm holding one in my hand right now. This is exactly what it looks like if you were to take a PS4 controller apart. And this is essentially how most analog joysticks work. It's just packaged differently. There are two potentiometers on an analog joystick. One of them is for the y-axis, which is forward and backwards, and one of them is for the x-axis, which is left and right. So if I push this joystick forward, you can see that the potentiometer, this little white piece in the center of it, is going to move with the joystick. And if I go backwards, it's going to move in the opposite direction. When the joystick centers, this little white piece centers within the potentiometer. Same way in this direction. So if this was left and right, you'd push it left and it'd go one direction, right and it would go the opposite direction. And then of course, if you went diagonally, it's going to turn both of these potentiometers at the same time. The way these are wired up is you have a reference voltage that goes in this pin here, you have a ground that goes on the outside pin, and you have the signal that you want to send to your board, and in our case it's the Brook Wireless board. That is the middle pin. Now, how does this work? Well, what happens is in the Brook board case, it has a reference voltage that goes to a joystick just like this. So when you're wiring up an analog stick in the Brook board, it's expecting a design similar to a regular PS4 or Xbox controller. So it's going to put an input voltage in here, and that voltage can be anything. In the case of the Brook board, the reference voltage is going to be around 3.3 volts. And this potentiometer uses that reference voltage and changes it among the range of the potentiometer. So in this case, the joystick will move so many degrees, and I think this joystick right here moves about 30 degrees in each direction. So that's 60 degrees total. And what it does when it's centered, when the potentiometer is centered, it's cutting that reference voltage in half. So let's assume that the reference voltage was 4. when the joystick is at center, then the output that's going to our board is going to register at 2, because that's half of 4. If I move the joystick extreme in one direction, so in the positive direction, then that voltage is going to change to 4. It's going to match whatever the reference voltage input is. And then the opposite of that, if I go all the way backwards, it's going to be 0. So your reference voltage is the maximum, 0 is the minimum, the center is going to be half, so that's 2 in our example, and then you can have anything in between that. So if you move it not all the way forward, but halfway forward, it's going to be at 3. If you move it just barely, then it's going to be slightly above 2. So you have a full range from 0 to 4 that the signal is going to send to the board. And it's the same way on the other axis. So the other axis works exactly the same way, and the input voltage is going to be the same. You're using the same input. So that's how these joysticks work. And the voltage can fluctuate. I mean, in the case of the Brook board, when you turn it on, this input voltage is around 3.3. But that could vary a little bit from board to board, and it could vary depending on, in the case of the wireless function that we're using, the voltage could fluctuate a little bit depending on how much your battery is charged. And that's important to note whenever we start talking about the UltraMark 360 joystick. So let's talk about that one now, and we'll discuss how it works. Let's take a look at the UltraStik 360 analog joystick. Now this is a really nice joystick. You can do a lot of stuff with it. You can plug it into a PC and you can go to their website and download software, and you can reprogram it to make the motions of the joystick do different things, diagonally, sideways, whatever it is you want to do. You can make custom mappings for it. Now again, these are designed for arcade systems and not necessarily raw analog, which is what we're trying to get out of it. Now this joystick operates off of completely different technology than the potentiometer design that we looked at earlier. So this joystick uses a Hall effect sensor, and a Hall effect sensor is a sensor that detects magnetic fields. So there's a Hall effect sensor on this PCB right in the middle, and on the end of this joystick shaft there is a magnet, and that magnet sits right above the Hall effect sensor. So when you move the joystick shaft, the magnet on the end of it moves with respect to the Hall effect sensor, and that changes the magnetic field. The Hall effect sensor senses that magnetic field change, and it converts it into information that can be used to identify the location of the joystick shaft. Now this style of joystick is used in a lot of industrial applications, and that's because they're very reliable. They're more reliable than the potentiometer design because there's fewer moving parts. They're also very accurate. The downside is they require power in order to work. So the potentiometer design does not require power. We are putting voltage into it, but it's not powering anything. It's just using that as a reference, and it's changing that voltage and sending it back to the board, and that's how it determines where the location of the joystick shaft is. The Hall effect sensors require a voltage in order to work. And in fact, the voltage that is required is a pretty tight range. So in the case of the UltraStik 360, these are designed to run off of USB power, which is 5 volts. And so that's one reason it doesn't work well with a Brook board, is there's no 5 volt pin coming off of the Brook board. And I say that there actually is a 5 volt pin, but Well, from what I found on the bench testing, is it's not a reliable 5 volts. It's not reliable enough for the UltraStik 360 to be powered regularly, especially off of battery power. So that's one reason that these joysticks don't work well with the Brook board. The other reason is, in order to get raw analog out of this joystick, it actually requires special firmware. And this firmware isn't available on Ultramark's website, but you can email them, tell them you're looking for the raw analog firmware, and they'll email it to you. And I uploaded the firmware onto this joystick here, and it does work. But the way that it works, the analog signals come out of these pins right here. It has a pin for the x-axis and a pin for the y-axis. And when you're using raw analog, it spits out half of 5 volts. So it's assuming that you're on a 5 volt system and that you need 2.5 volts when the joystick shaft is at center. So then the full range is, if it's all the way forward, it's 5 volts, all the way back is 0, and center is 2.5. Now, as discussed earlier, the Brook board doesn't operate on a 5 volt system. The reference voltage is around 3.3 volts. So what happens is, when you're sending the Brook board 2.5 volts when the joystick is at center, the Brook board reads that as it should be moving either in the forward direction or to the right direction. So you're going to get joystick drift, which means when the joystick is at center, your character or whatever game you're playing, that joystick is constantly drifting to one direction. Now, I want to be clear that there's nothing wrong with the UltraStik joystick, and there's nothing wrong with the Brook board. They're just two different technologies that aren't necessarily compatible with each other. However, I have some ideas to fix both the problems, both the power issue and the 2.5 volt signal issue. I want to get this analog joystick to work because it's the form factor that I need, but it's not a long-term solution for me. I don't care if it's band-aided together. I just want to test the rest of the functionality of the Brook board. And in order to do that, I need some kind of analog capability. So I'm going to put band-aids on this to make it work so I can test other things. Once I've vetted all of that stuff, then I'll come back around and get a better solution for the analog joystick. Okay, so here we are. I'm going to use, this is actually the second controller that I built for myself so that I could also test this at the same time as my nephew. And mine's a little bit different layout than the other one because I have use of my hands, so I made it convenient for me. These two joysticks right here are UltraStik flight sticks. So they are the same as the UltraStik 360 joysticks, except they have these buttons here that you can use for other things. And I chose this for myself because for PlayStation, I'm not a PlayStation player. I'm more of a mouse and keyboard guy, but the L2, L1, R1, L2 in shooter games, I know you use those a lot, so that's why I went this route, and I'm planning on doing L1, L2, R1, R2 with these 4 buttons in some combination. I don't really know which combination because I just don't know PlayStation games that well, but I also modify these controllers with buttons right here as well. And these buttons are going to be the L3, R3 buttons, which is when you press down on the toggle sticks on a PlayStation controller. That's the L3, R3 button there. So I'm going to modify this controller, get it working so that I can really strain it and test it out and see if I can get it to work, what works well and what doesn't. Okay, so this thing is a real mess. I mean, the other controller was a big mess, but this one's even worse. But that's okay. I promise I'm gonna fix this at some point, but it's not gonna be right now. In fact, I'm probably gonna get rid of this entire design and go to something more modular, but for the testing, this is what we're gonna do. So here are the analog joysticks that we need to modify. So first, let's start with the power problem. We got to be able to run 5-volt power to it, and that's going to be really easy. What we're going to do is we're going to run power through the normal USB power slots. And hold on, I've got cables around here somewhere. Here they are. So what I did is I ordered a splitter. So on one side is, I think these are mini USBs. They're not micro, so I think micro is what old phones, or the last generation of phones use, I guess. The new generation is USB-C. The generation before that, I think, is micro USB. And these are mini USB. And the UltraStik joysticks all come with a USB cable that attaches to these. But what I did is bought a splitter, so I've got a mini USB female into 2 male mini USBs. And what I'm going to do is I'm going to plug one end of this into each joystick. Just like that. And then I'm going to run this end, the female end, outside of my box, like so. So I'm going to drill a hole. Actually, I'll probably just let it hang out like this and put the lid on, put a screw in it or something. I don't care for this testing how pretty it looks. I just need it to be functional. So I'm going to hang this out, and then what I'm going to do is I'm going to take another USB cable and I'm going to plug a micro USB, one of them that came with the joystick. I'm going to plug that in here, and then the other end is going to be just a regular USB plug, and I'm going to plug that into a phone charger. And that phone charger is going to run both of these. It's going to run 5-volt USB power to both of these joysticks at the same time. And the power problem is solved. The downside to that is that you're always going to be tethered to a cable. So we have wireless fight board that we can connect to a PlayStation wirelessly, but we have to use a USB to power the joysticks. So that's the downside, but again, this is just, we're going to get it to work, do some tests, and then we'll come up with a different solution. Now, for getting the outputs to be the voltages that we're looking for on the Brook board, we're going to use potentiometers. Alright, so I got rid of the controller so that we can only focus on the joystick. I'm going to try and explain this in a least confusing way as I can. So I apologize if this doesn't come across as simple as it is. This is actually a really simple thing that we're going to do. So what we know is that 2.5 volts comes out of the raw analog signal of the UltraStik 360 joystick. And you can see the pins, the pin out right here. And we're only going to use 3 of the 9 pins. Okay, so 2 of them are going to be analog signal out. One of them will be X axis, the other will be the Y axis. And then the third pin that we're going to use is the ground. So you can buy Ultimark, which is the place that sells this joystick, sells the harness that attaches to that cluster of pins. And that's where I got this harness right here. And on their website, they have the pin out that tells you what each pin does. So if you use this harness, the raw analog signals are the violet and the gray colored wires coming out of that harness. The ground is the black wire that's on the opposite side of the harness. So you could buy this and just use the 3 wires, and then the rest of this wire harness, all these right here, are worthless. So you can either cut them off or just let them hide in your box. It gets kind of messy if you do that, so I'm not going to use that. I have a bunch of these little guys. I bought several bundles of these, had them shipped from the Amazon, and they're really handy for doing stuff like this. You can test it. You can test individual pins. You can plug pin to pin. You can plug stuff into breadboard really easily. So I'm going to use these things for this test here. Okay, so what are we going to do? Well, the violet and gray pins, or the violet and gray wires coming out of this joystick, are on the very end. So one end has a pin missing. One side of this cluster has a pin missing. That one single pin right there that's under the pin that's missing is ground. On the opposite end of that, the top and bottom pins are the raw analog signals out. Now, I don't know which one is X and which one is Y, and it really just depends on how you mount your joystick in there. If you mount it in like this, then your Y is going to be that direction. If you mount it in this way, the Y is going to be the opposite direction. So it really depends on how you use it. It's going to be a plug it in, see which direction it's working. If it's not the direction that we're looking for, we just swap the wires. Not a big deal. Okay, so we know that 2.5 volts comes out of this raw analog signal. And that's too high for the Brook board, which expects 3.3 volts total, so half of that is around 1.5, 1.6 volts, somewhere in between there. So we need to adjust the 2.5 volts down. Now there's probably a lot of ways to do this. I'm going to do it in a way that I know will work, and I'm using simple materials. So what we're going to do is attach a regular potentiometer in line to that signal. So we're going to need a potentiometer for each signal. In this case, we have one for the X and one for the Y, so we're going to need 2 potentiometers per joystick. I have a whole box of these. Again, I had them shipped from the Amazon. I don't know how many I have. I've got a lot though, and they're all different resistances. So these are variable resistors, potentiometers, and I have 2 of them here in front of me. One of them is a 50K potentiometer, and the other one is a 100K potentiometer. And for what we're using it for, it doesn't matter. Both of these will work. It doesn't matter what the resistance number is. It's going to work for this application. So how do we do this? We're going to take the raw analog signal out. So we're going to plug a wire into there. And we're going to plug it into one of the outside terminals of the potentiometer. It doesn't matter which one. If we plug it in here, the only difference is going to be if positive is clockwise or positive is counterclockwise. So it doesn't matter which terminal you plug that one into, as long as it's an outside terminal. The ground, we're going to connect another cable to the ground of our joystick. So that's the one that has the pin missing. It's the one right below the missing pin. And for the sake of this demonstration, I'm going to plug the other end of that ground into my breadboard, because I'm going to have to connect 2 pins to ground. So that's just going to be my way of connecting the 2 and also connecting it to my meter so that we can see what's going on. So I also want to ground the opposite outside terminal of my potentiometer. So I'm going to plug that into ground as well. Okay, so what we have right now is the orange wire is my raw analog signal out, which we expect to be around 2.5 volts when the joystick is at center. And the black wire coming out of my joystick is running to ground. The gray wire running out of my potentiometer, the other outside pin, is also running to ground. So the gray wire and the black wire are connected together. Okay, hopefully that makes sense so far. Now we're going to take the purple wire, this purple wire right here, and we're going to connect it to ground as well. And we're going to tie that ground point to my multimeter. So now we're going to take this brown wire and we're going to plug it into the center terminal of the potentiometer. Okay, and that's going to be our signal out. So this would be, if this were connected to the system, we would connect it to the Brook board. So this is the voltage that the Brook board is expecting to see that determines the movement of your character. So we're going to connect that to the positive side of our voltage meter. We're going to turn that on. And what's going to happen is the joystick is going to send the output signal, which is going to be around 2.5 volts, through this orange wire. And we are going to be able to adjust the output voltage that's running to our Brook board, which in this case, we've got it plugged to the voltage meter, so we're just going to look at the voltages. So we've simulated what's going to happen in the system. Now, we're going to power the joystick with a USB cable. So this USB cable is just plugged into a power supply like a phone charger. And this is exactly what we're going to do in our final setup. We're just going to power it up with USB power. Okay, we got our green light come on, so we know that the joystick is powered. If I turn my voltage meter to read DC voltage, you'll see that it's at 2 volts right now. So if we max it out, we're at 2.61. If we go down to 0, if we go the opposite direction, we're at 0. So keep in mind that that's when the joystick is at center. So let's turn this all the way up. We're at 2.667. Okay. So if I move the joystick one direction, then we're going to drop down to basically 0 voltage. If I go all the way up, we're at 4.8 volts. And then if we go to center, we're at 2.7 volts. So that's with the potentiometer set at max, which means that if you were to take this potentiometer out of the equation, the voltage coming out of the joystick is 2.7 volts, so it's a little bit higher than 2.5. So again, to fix this, we want to adjust this down to, let's say, 1.5. So we just turn our potentiometer until our voltage meter is reading 1.5. 1.494, that's close enough. So now, when we move our joystick, if we go one direction, we go down to 0 as we expect. But when we go to the other end of the spectrum, we're only going to 2.64, 2.65 volts. See? So now we've adjusted our joystick at a level that the Brook board can tolerate. Now the Brook board, I don't know if it's the Brook board or the software that I use on my PC to do the testing, but there is like a dead zone there that can tolerate some variation of the voltage. So even if it's not perfectly at center, it may still work. So hopefully that explains what we're doing and how we're fixing the problem. We're just dialing in the voltage that we want to see with an added potentiometer. Now I'm going to get all of this installed in the system, and then we'll measure the voltage of the Brook board reference voltage, and we'll compare it to this. We'll dial everything in, and then we'll see if it works. Alright, I got updates. So I've got all the potentiometers wired up. Again, there's one for each axis for each joystick, so there's 4 total. And again, I really apologize for this wired up mess here. You're just going to have to trust me that I wired in the potentiometers like I said I was going to. So now that we've got the potentiometers wired in, the next thing we got to do is tune them to the voltages that we want. And the way to do that, I've already done that, but I'm going to show you how to do it. First, we need to know what the reference voltage is, and the reference voltage is in this cluster right here. So on the Brook Wireless Fight Board, if you look at the diagram that is provided with this board, you'll see that the analog pins all plug into a row of pins at the back of the board, which are located right here. And the board is labeled on what is what, so it's labeled, just for example, if we're talking about the right joystick, there's RX, there's an RX pin, there's an RY pin, and there's an R3 pin. So the RX pin is the right joystick in the X direction, the RY pin is the right joystick in the Y direction, and the R3 pin is the button on a PlayStation joystick. If you push the joystick down, that is the R3 button. And then of course there's the same labels for the left joystick. And then on the opposite ends of that row of pins, there is a ground, which the wireless fight board is a common ground, which means all of the grounds are connected together. So you can connect ground at any location you want on the board. I have a lot of the buttons and the joysticks all tied into one ground, and then that one ground is ran to one location on the board. And then the opposite end of the ground is labeled VCC, and that is the reference voltage. Now, since we're using the UltraStik joysticks and not a regular PlayStation joystick like this guy, we are not using the VCC connection, but we do need it to calibrate or tune in our potentiometers. So we need to know what that voltage is reading. I'm using a breadboard because I have one, but you could measure it directly on the board with a voltmeter. You just want to probe that pin with the red lead and then connect your black lead to any ground. It doesn't matter which ground it is. So I have the black lead just attached to a ground on one of the potentiometers, and then the red lead I'm going to attach to a lead coming off of the breadboard, which I have this red wire right here plugged into the VCC pin on the wireless fight board. Okay, so I'm just going to put a jumper wire into my breadboard so that I can pull the voltage off of VCC. So I'm going to tack my alligator clip to it, which is attached to my red lead here. And you'll see that the reference voltage VCC is 3.305. So we want to tune our potentiometers, since our joysticks are at the 0 position. They're straight up and down. We're not pushing forward or sideways on them. We want the voltage reading out, so our center pin of our potentiometers, we want that to be half of 3.305, which is 1.65. Okay, so now that we know what the reference voltage is, we just take that and we divide it by 2, which is 1.65. And then we're going to take our positive lead. So now we're reading 0 because I just disconnected it. And we're going to connect it to one of our potentiometers, the center pin. So remember, the center pin is the one going out to the Brook board. So there's going to be one for the X and one for the Y for each joystick. So I'm going to put my alligator clip on the center pin of one of my potentiometers. Okay, and I've already tuned these in, so this one's reading 1.663. The reason it's not 1.65 is because I tuned it in and then I moved the joysticks around just to see what would happen, and they did change a little bit, which I expected. So I'm going to go ahead and rotate this potentiometer just to show you what happens. See, if I turn it one way, it goes up. If I turn it the other way, it goes down. So I want to try and get it as close to 1.65 as I can. And it's pretty sensitive, and a fluke meter is pretty sensitive anyway. So if you get it close, you're good. So 1.648, that's very close to 1.65. Okay, so that potentiometer is tuned in. That's where we want it, and we're going to do that for all 4 potentiometers. Now I've already done that, so if you need help, just rewind the video and watch it again 4 more times, and you'll be good to go. Now, I have built, just for my testing, I have built this box that will display the voltages of all of my axes at any given time. So the top voltage meter is showing the reference voltage, which is 3.3, which is what we measured. And then these 2 voltage meters here are measuring the left joystick. So this is the X direction and this is the Y direction. And then these 2 voltage meters over here are reading the voltages on my right joystick. And what's going to happen if I move my joystick, so I'm moving one of the joysticks now, and you'll see the voltages change, which is exactly what it's supposed to do. And as I'm playing, that's just going to be moving constantly. Those voltages are going to be changing, which is good. The reason that I wanted to monitor it, I don't really care about what happens while I'm playing the game, because these voltages are going to change so quickly that these voltage meters are not going to be able to keep up. And that's fine. What I really am interested in are 2 main things. One is I want to know if the reference voltage changes over time or if it stays pretty consistent. The other thing I want to know is if I do start to see joystick drift, I want to see if the voltages coming out of my joysticks are changing. And it's okay if they change a little bit. I mean, as you'll see here, now this one's at 1.63, this one's at 1.64, so it didn't stay at the 1.65 that I originally set it at. And that doesn't necessarily mean that it doesn't work, because there is a dead zone in the joystick that accommodates some changes in voltage or some variation in voltages. But if it gets too far out, that's when we're going to start to see joystick drift. So this box is just a way for me to quickly see if I start to notice some joystick drift. I'll be able to quickly see which is happening. Either these are changing, these voltages are changing a little bit, or the reference voltage is changing. Now I suspect that what will happen, I do think that these are going to change a little bit, but I don't know how much. And I suspect that this could also change. Now I'm plugged into USB power now, and this is staying pretty consistent. I have a suspicion that if I were to use the wireless capability of our board, so I'm not using a USB cable, I'm just using battery power and connecting wirelessly, I think that this reference voltage may change depending on how charged the controller battery is. So what I'm going to do for this testing is I'm going to first have everything plugged in, and I want to play PlayStation. I need to put some time into this. I need to play a game for an hour or two, or 3 or 4, however long it takes. And I'm going to do that with it plugged into the PlayStation and see what these voltages do. If that looks promising, if I can get several hours in with no joystick drift, then I'm going to unplug the USB, plug in my battery to my board, and do the exact same thing. And I want to put several hours on it, see how much battery life I get, see if my voltages change with time. And then if that works, keeping in mind that my joysticks are going to be plugged in to a USB power at all times. So if I can get the board to work wirelessly and consistently with a lot of play time, then I may come back and see if I can find a wireless solution for my joysticks. And what that means is I get another battery in here to power only the joysticks, or I may find a way to power it from the board. I don't know. But that's where we're at now. So I'm going to button all this up, and then I'm just going to play some games. And I'm going to report back to you on what I find, and we'll see how it goes. There are a couple things that I forgot to tell you. For starters, I did end up using the harnesses that come out of the joysticks, because the little single pins that I was trying to use don't stay on the pins very well, and I didn't want it to all come off while I was transporting it or whatever. So I did use these, and then I just spliced into the gray and violet wires like I discussed previously. The other thing I wanted to mention is, before buttoning this up, I did put electrical tape over the potentiometer leads, so that when they bang against each other, since I've been really sloppy about all of this, I don't want the stuff banging into each other and shorting out, so I did wrap some electrical tape around that. I also soldered everything together instead of putting those pins, those individual wires together, because again, I had difficulty with them staying on there. So that's all I wanted to say. Alright, we've got some updates. So I've been playing with this for about, I don't know, I probably got 4 or 5 hours of game time using this controller. And there were a few things that I noticed right off the bat. And one is that I wired these voltage meters up backwards. So the meters on the left are actually for the right joystick, and the meters on the right are actually for the left joystick. So that's super convenient. But other than that, it's working just like it should. You can see from the voltages here, so let me walk through what we've got. So I've got my PlayStation, this is a PS4, I've got it hooked up, and I've got my controller back here with a USB line out plugged into my PlayStation. and that's what powers the controller itself. So that provides power to the Brook Wireless Fight Board. I also have the USB coming out that's just plugged into a regular phone charger, so a USB to a regular outlet plug. That is powering my joysticks, so the two UltraStik joysticks. And then I've got my signals coming out going into my voltage box, and that's what gives us the voltages on here so we can monitor what the joysticks are doing. Now there's a few observations that I noticed right off the bat. One of them is when I plug the controller into the joystick so that the whole system is powered, the voltages actually increased. So when I calibrated the voltages to 1.65 volts, I did that with only the joysticks plugged in. I did not have the controller itself plugged in, so there was no power going to the Brook board. And when I plug it into the PlayStation, these voltages jumped up to around 2 volts. They're just under 2 volts right now. Now I've been playing like this. I have not done any recalibration since I realized this. So the joysticks, when they're at center, which they are now, they're around 2 volts, and I haven't noticed any joystick drift. So what that tells us is we can go up to 2 volts and still be okay as far as joystick drift is concerned. So that's good. That means that there's a variable voltage that still allows dead center. Okay? I do think that we're on the edge though. I think much more than 2 volts and it is going to start to drift. The other thing I noticed is this 3.3 reference voltage here, which is what is measuring the VCC pin on the Brook board. It has been consistent 3.3 volts. And I didn't expect that, I'm going to be honest. I thought that this 3.3 would fluctuate a little bit, and it has been a suspiciously steady 3.3 solid. And I have plugged and unplugged the controller multiple times. I've turned the PlayStation on and off multiple times. I've been playing this for I think 3 days now, and cycled back and forth for days, and it's still been at 3.3. So that's actually really impressive and good news, I think. So what I want to do is I want to recalibrate these with the PlayStation on, with it connected to my controller. So I want to bring these voltages back down to 1.65. And in fact, if I unplug it from the PlayStation, you'll see that they drop. So now we're down to about 1.6, 1.65. So it's stayed approximately where I calibrated it, which is good. So this is all good news, I think. It's working better than I expected it to, which I had my expectations set pretty low because I don't like to be disappointed. So I just plugged it back into the PlayStation, and you can see that the voltages are now back up to 1.8, 1.9. So we're getting consistent results, and I like consistent results. Even if they're bad, as long as they're consistent, we can figure things out. One more thing that I noticed is if I pull the controller up here so you can see it a little bit better, and hopefully you can see these numbers. I'm not sure if it's too far away for you to really see what's going on, but I did notice that these joysticks are very sensitive. So if I just touch one of these joysticks, so this is the right joystick, so the left voltage meters are going to change. If I just barely touch that, see how it jumped up to 2? And if I move it the other way, it jumps down to 1.8. That's still considered at center. So I'm just barely touching it with my finger, and these voltages are changing by about 2.2 volts either way. So that's something to keep in mind if you're calibrating these things. If you don't have them directly in the center and you calibrate them to 1.65, if you just barely touch them, they're not going to be at 1.65 anymore. I don't think that really matters in the long run though, because we've already seen that we can be well above or below the 1.65 or the center of 3.3, and it still works without joystick drift. But I just wanted to point that out, something I noticed. Other than that, it seems to be working okay. This D-pad joystick that I have, or the joystick that's supposed to work the D-pad, that is not working, and I'm not sure why. I didn't really chase wires like I should because I was excited to try it. So I'm going to take this back apart. I'm going to recalibrate with power running to the Brook board, and then while I'm in there, I'm going to see if I can fix this. Everything else is working like it should, so I'm really excited. For those of you that claim to have gotten the UltraStik joysticks to work without doing anything special with potentiometers or whatever that I have done, I'd really like to hear from you. How did you do it? Am I missing something? You know, I scabbed this together just on a basic understanding and assumption of how I think the system works. But I could be completely missing something, and it may just be connecting a pin to a different pin and the whole thing works 100%. So if there's something easier that somebody has figured out, please leave a comment and let me know, and maybe I'll make a different video showing everyone how to do it simpler and less stupid than what I just did. Thanks. Got more updates. Update number 72. I was able to fix the D-pad joystick. Turns out I just didn't connect any wires to it, so that's why that wasn't working. Got that all connected up and it's working fine now. And then I played with it. I recalibrated my joysticks like I said I was going to. And I played with it for an hour or so and everything was working great. I think the joysticks were a little bit more responsive when I recalibrated them with the joystick on, so that's good. And then for fun, I plugged the battery into the Brook board and unplugged the controller from the PlayStation just to see how that would work. So I played with that configuration between 3 and 4 hours, and it's working really well too. So I monitored the voltage and we stayed at 3.3 volts with running on battery power, and of course the battery was fully charged when I first started playing that. So I'm going to monitor it as I play longer, and as the battery starts to run down, we'll see if that changes anything. But the fact that I got 3.5 to 4 hours out of it, I'm satisfied with that. So from this point, it's just seeing what happens when the battery does run down. And one other thing that I wanted to potentially make a correction on, because I'm not sure what I said previously, but moving the joysticks forward causes the voltages to go down to 0, and moving them backwards causes them to max out. So in this case, 3.3 volts. I think I said that backwards before because it's counterintuitive. I just assumed that pushing it forward made the voltages go up, but that's not the case. So yeah, that's it. I'm gonna continue playing around with this controller just to get a better feel of what things do with time, but I think that's gonna do it for this episode. Thanks for watching. Pretty soon I'm going to make another video where I'm going to completely get rid of this entire design, and I'm going to switch over to a modular design similar to the Microsoft Adaptive Controller. If you haven't looked at that, check it out. If that sounds like something you might be interested in, stay tuned, and it's going to be a lot of fun if I can get it to work. Thanks for watching, guys. Appreciate it.